Next up we have reliability. It means the language should be dependable. It shouldn't have many bugs. If errors are appearing in the language, then it should have the flexibility to handle it through error handling or exception handling. So now let me show you some example. If x equals 5, the program should see out x equals 5. If we are writing this code in C++ or C language, what it will do is whatever the value of x is, for instance int x is equal to 0, whatever the value of x is, it will just change it to 5. This will not check what value x has, it will just change the value to 5 and then it will print x equals 5. On the other hand, if such a statement is used inside the if structure of a Java program, this would not execute. Java would result in an error. So this means that Java has higher reliability as compared to C or C++ language. Similarly, suppose you are making a calculator program. You are now asking a user to enter any number. But what happens if a user enters an alphabet to calculate? Like, for instance, suppose you are doing an addition. Now you are asking user to enter a number, but what happens if a user enters an alphabet? So what will the program do then? So the program should have the flexibility to handle such cases. The output should be please enter a number. It shouldn't crash. It should give the output to the user in a very friendly manner that you're supposed to enter this number, not of this type. It shouldn't just go on to crash. This isn't a trait of a reliable language. So you can avoid this crash by doing the exception handling. Next up we have maintainability. Maintainability basically means that a program should be easy to change. So it basically depends upon the programming language being utilized as well and the efficiency of the programmer. So for instance, if we have to modify a program or if we have to extend the program, our code should have the flexibility to provide ease modification or ease extension. For instance, if we have a program of different shapes, we have circle, we have rectangle, we have square, and now we need to introduce another shape, for instance oval. So good maintainability would require that you add the shape, the new shape, the oval shape to our list of shapes without changing the previous code. So this is what is meant by maintainability, and we can achieve this by using functions, classes, through polymorphism. In the upcoming videos, we will have plenty of more lectures on the classes, functions, polymorphisms. So for now, this is all good. You just need to understand that through polymorphism and these functions and classes, we can have maintainability. And through named variables or named constants, we can also have maintainability. For instance, let me demonstrate this through a short code. So for example, we are calculating text. Given this hard coded, now I would have to change this in every instance, in every statement where I am using it. So it can get difficult, and if I leave any statement or any line of code, then the whole program would get inaccurate. So the approach here in maintainability is to use a named constant or a named variable instead of a numeric literal. Write the text variable here. Next up we have abstraction. So this is a topic that has confused me a lot in the past when I was learning object-oriented programming. And I believe that for others as well, this word can get a bit tricky and a bit complicated. Whenever they see this word, they're like, should I use inheritance? Should I use polymorphism? But what is actually meant by this? So abstraction hides implementation details and provides easy to use interface. So this is a topic that demands a fully extended video of its own. I don't think I can make this right now in this video, as this video is already too long. But I will be explaining abstraction in the upcoming videos in much greater depth. Basically, a good portion of this course uses inheritance, interfaces, polymorphism. So we will be using abstraction again and again. And when we do so, I will be explaining abstraction and all of these other topics in a great details. Next up we have modularity. It means that our code should make use of small units or small functions that each of them performs a specific different task. It shouldn't be like so many different tasks are performed in one unit or one function. Let me demonstrate it through an example. So for instance, we have a calculator class calculator, and inside it we have different attributes, int, etc., int a, and so on. And there we have our functions public. We have addition function that takes two variables and adds them, int a, int b, right? And we have subtraction function that takes parameters, multiplication functions that takes parameters, and division, etc. So this example has high modularity because it has different functions that each of them has a specific different task. But if I combine these functions into one function, that would mean low modularity, or it would mean a monolithic function. For example, I could do int calculate. Now it could ask user, what do you want me to calculate? Do you want me to perform addition? Addition is also defined here. Addition is defined here. All other functions are defined here. So this code has low modularity and it isn't a good programming practice. A good programming practice, as explained in the previous example, it should have different functions and each of them should have a distinct separate task that should be separate or independent of other functions. Independent development means the programming language should provide construct to support independent development, and the programmers should be able to code in parallel. So this basically means that the programming language that we are coding in should have the flexibility that different programmers that are making a big project, they should be able to code in parallel. For example, each programmer can be assigned a number of functions and they can code in parallel. So different programmers would work on different functions and they are all contributing to one big project. So this is what is meant by independent development.